Hello everyone, I'm Mr. Pinola, and today we're going to take a look at some of the uses of the electromagnetic waves that we learned about last time. You might recall from the last time that we spoke that there are 7 different types of electromagnetic waves, 6 of which humans cannot see. On the board behind me is a list of those 7 types, ranked in order from lowest frequency, which is radio waves, to highest frequency, which is gamma rays. They're also ranked in order from longest wavelength, radio waves, to shortest wavelength, gamma rays. And you'll notice that visible light, Roy G. Biv, those colors that we can see as humans, those are right in the middle, with anything to the right of visible light being too high of frequency for humans to see, and anything to the left of visible light being too low of frequency for humans to see. But today we're going to explore how do humans use the different types of electromagnetic waves. Even though we can't see them, there are lots of different ways that we can use the 7 types of waves on the board behind me. Let's start with radio waves. So before we get into radio waves, I want to ask you a bit of a trivia question. Do you know what building this is? If you said that it's the Burj Khalifa, which is a huge building in Dubai, which is a city in the United Arab Emirates, you'd be correct. The Burj Khalifa is the tallest building in the world, taller than the Empire State Building, taller than the Willis Tower in Chicago, taller than any building in the United States or in any other country. But do you know the second tallest structure that was ever made? Notice I said structure and not building. And I also said was ever made, not is currently standing. That would go to this object. This is a humongous tower that was built in the 70s in Poland. It's called the Warsaw Radio Mast. And the Warsaw Radio Mast is no more. It fell down in 1991, and it collapsed, leaving a pile of rubble that looked something like this. However, when it was first constructed, the Warsaw Radio Mast was the tallest man-made structure in history. And it wasn't until into the 2000s that the Burj Khalifa passed the Warsaw Radio Mast in height. But the Warsaw Radio Mast, if you look at it compared to a lot of these other tall buildings that we know, is significant because not only was it a really tall structure, but also because of what it did. The Warsaw Radio Mast sent radio waves across much of Eastern Europe when it was in use. And so let me draw a crude picture of the Warsaw Radio Mast. Here's the tower, and it was held in place by really long wires. Okay, these weren't actually part of the structure itself, but they tried to keep the structure from falling down. And so the radio mast would send out radio waves, the first kind of radio wave that we're going to be talking about today. Now, people couldn't stand next to the tower and listen to the radio. It didn't work that way. Instead, in everybody's home, they would have a radio. Perhaps a device that looked a little bit like this, with an antenna. Maybe you have one of these at your house, or maybe you have one of these in your car. Well, the radio waves from the radio tower, and there are many of these around the globe, the Warsaw Radio Mast wasn't and isn't the only one, would send out radio waves that would be collected by radios all over the place through their antennas. And so the waves would travel throughout space, and they would be collected by the antenna. Now, if you've ever been in a car and tried to listen to the radio on a long road trip, you know that radio waves are very easily blocked by things like mountains or tall buildings. And that's why the Warsaw Radio Mast needed to be so tall, so that it was taller than everything around it, so it could send the signals without having them blocked by other objects. The reason that radio waves are blocked so easily is because they have such a low frequency, and therefore they have very little energy. And so radio waves don't actually carry the sound to our ears. That's what we hear after the radio is turned on. However, the radio waves that were used in radio towers, such as the Warsaw radio mast, are used to carry radio signals to electronic devices. And so that's our first use of radio waves that we'll write down, that they carry signals to radios. These could be radios in your car, or they could be radios in your home. However, that's not the only use of radio waves. Don't let the name deceive you. Radio waves can also be used to carry signals to televisions. Televisions? TVs, you're saying? How do those use radio waves? Well, in a similar way. Maybe you've seen a house that has a structure like this on its roof. These aren't quite as common anymore, but this is an old-time TV antenna. Now they might look a little bit different, but the TV antenna used to collect radio waves, and it would turn those radio waves into the sights and sounds that would be on your TV. And so televisions, or at least ones that operate by using antennas, would also be another use of radio waves. For our next type of wave, we're going to move over to a wave that has a slightly higher frequency than radio waves, but still too low a frequency for humans to be able to see. That's, as you might have guessed, microwaves. Microwaves like this one in front of me work on. So to demonstrate how a microwave works, I'm going to take a couple marshmallows from this bag. And I'll put that bunch of marshmallows on a paper plate in front of me. There you go. You can get a sense for what they look like. And let me put them in our microwave. I'm going to set our microwave for 1 minute. And the marshmallows will be exposed to the microwaves that are inside our microwave oven. Certainly smells like I've been cooking marshmallows in here. Once we open up the microwave, you immediately see what happens. Do you see how big our pile of marshmallows is? Definitely not as big as it was before. And so the marshmallows have grown. Clearly, not everything grows when it's put in the microwave, but what happened here was that the marshmallows absorbed some of the energy from the microwaves inside our microwave oven. And so one use of microwaves is that they can be used to cook food inside microwave ovens, such as this one. So microwaves can be used to cook food in microwave ovens. You probably guessed that based on the name, but let's write that down as our first use. However, microwaves are a type of wave, and they have other uses beyond just cooking food. In fact, many of you probably have a cell phone on you or near you right now. Did you know that cell phones use microwaves? In fact, if you have a cell phone, chances are you're either planning to send or receive data, maybe either through a phone call or through a text message at some point today. Those signals that you either send out or you receive are actually microwaves, the same category of waves that was used to cook our food. Now, these ones aren't quite as strong, but they still fit into the same general category of microwaves. So, microwaves are used to not only cook food in microwaves ovens, but they are also used to carry cell phone data. Don't worry, microwave ovens and cell phones use microwaves because they have low energy compared to a lot of the other types of waves on our spectrum. So since they have such low energy, which is mainly due to the fact that they have very low frequencies, they aren't really dangerous to humans. So don't go throwing out your cell phone right now. For our next type of wave, we're going to take a step back into the kitchen again. But we're not going to use a microwave oven this time. This time, we're going to use a conventional oven. I've been preheating this oven for about 20 minutes, and right now it's at about 350 degrees Fahrenheit. When I open it up, there's nothing inside, but I can feel that it feels really, really warm. These are heat waves that are traveling that are warming up my body. Heat waves are also known as infrared rays, and those are the next type of waves on our electromagnetic spectrum. So infrared rays, also called IR rays, are rays that have slightly higher frequencies than microwaves, but still lower than visible light, so we can't see them. Infrared rays are typically heat rays, and they can be used in any way that heat would be needed. So for example, they can be used to heat food, either through a standard oven, not a microwave oven, or perhaps a heat lamp. Maybe you even have a pet reptile, like a snake or an iguana, that might sit in a tank that uses a heat lamp. That could be another use of infrared rays. But there's one really neat use of infrared rays that doesn't involve directly heating something. Instead, it involves measuring the heat that's already coming from something. And that's called making a thermogram. A thermogram is a picture that shows you where the warm and cool areas of an object or a place are. Let's take a look at a thermogram and see how they're used. Here's a thermogram of a house. Notice somebody took this picture and measured the IR, infrared rays, that were coming from the house. You can clearly see that the areas that are more red, sort of around the chimney over here, are where there are warmer temperatures. What that means is that there were more infrared rays coming from this area, and we can clearly see that in our picture or our thermogram. Notice that the tree that's behind the house doesn't have as many of these red colors in it. That means the tree is at a lower temperature. There are not as many IR or infrared rays coming from the tree. Now that we've covered radio waves, microwaves, and infrared rays, the three types of waves that have lower frequencies that humans can see, we finally arrive at the types of waves that humans can actually see. And that's visible light. And we know visible light because of the colors of the rainbow, Roy G. Biv. We can clearly see those colors. Now, most visible light that we know of comes from the sun. The sun is a great source of visible light, but you won't see the sun having red, orange, yellow, green, blue, and indigo and violet rays. That's because the sun gives off white light. And that white light, as we saw from our prism experiment the other day, can be broken into the different colors through refraction. So visible light comes from the sun. And that lights everything up so that we can see it. But other things can give off visible light other than the sun. For example, here I have a laser. And I'm going to shine that laser and spray a little bit of that fog in the can that we saw in another video to show you what the laser looks like as it travels through space. Here I'm shining my laser on the far wall. And here you can see the red beam of light that's coming from the laser. Well, this laser carried red light. And red is the type of visible light that has the lowest frequency. But let's take a look at another laser. You can clearly see violet light coming from this laser. That means that that laser carried the highest frequency of visible light, violet light. And so if I shine both of them together, you'll be able to see that they are both carrying visible light through space, but that one of them has a lower frequency than the other, and we know that because of their different color. And here they are again. You can see the violet light and the red light. Two different colors with two different frequencies of visible light. So why is it important to have different colors of visible light? Well, sometimes that can keep us safe. For example, think about traffic lights. The red and the green light and the yellow light of any traffic light helps keep us safe. If red and green look the same, it would be way more difficult for drivers to know when to stop and when to go. Another use of visible light could be in neon signs. Maybe you have a business near your house that has a brightly colored sign outside that can be lit up. Well, that sign likely has a bunch of different colors in it, and those colors appear different to humans because of the different frequencies they have. Yet we can still see all the colors because they all fall in the visible light spectrum on the electromagnetic spectrum itself. Maybe you guessed what's coming next. Now that we've covered visible light, now we have to get into the colors that have higher frequencies than visible light. We just learned that the highest frequency of visible light is violet, so it makes sense that the next category would be ultraviolet, or ultraviolet rays, or UV rays, which have frequencies that are just too high for humans to be able to see. But they're still all around us. Let me show you how we know that. So today we're going to see that visible light is all around us, but so are ultraviolet or UV rays. Here are two containers that each contain a bunch of beads. These are special beads. They change colors when they detect ultraviolet or UV rays. I'm going to take one of these containers of beads and leave it right here on this table in front of the camera. And I'm going to take the second container and put it in the window. It's not the sunniest day, but there is still some sunlight outside. And the sun, even though we know it gives off visible light, also gives off ultraviolet rays. Let me go put it in the window and we'll take a look at what happens after a couple minutes. Even on a day that's not particularly sunny, I think we're still going to see that the beads pick up some evidence of UV rays. Let's go take a look at them. These are the beads that were just sitting in the window. You might notice that they have like a pinkish, purplish tint to them. That's because the beads have detected that there was UV radiation in the sunlight. These were the original beads that were sitting on the table. Notice they don't have that pinkish or purplish tint. That's because they were sitting in the classroom under regular lights, not sunlight. Regular lights don't give off UV radiation, but the sun does. So as we just saw, the sun gives off ultraviolet rays in addition to visible light, and infrared rays as well, because the sun also heats humans. But let's focus on the ultraviolet rays for right now. A nice benefit of the sun giving off ultraviolet rays is that it allows humans to get vitamin D. Maybe you've heard of people who are in a better mood when they're outside and it's sunny. Maybe that's you. That's because the sun, through the ultraviolet rays, helps humans get vitamin D, which is a good thing. That allows us to be a little bit happier and be a little bit healthier. However, there are also negative effects of that. The fact that the sun gives us ultraviolet rays can also do other things to us. It can cause skin cancer. And that's an unfortunate side effect of sometimes being in the sun too long without proper protection or sunscreen. So if you go out and the sun is really strong, be careful, because there are also a lot of ultraviolet rays, and you want to make sure that you're prepared with the right sunscreen to protect you from those harmful rays. Now, there is one other aspect of ultraviolet rays that humans use, and that's the fact that ultraviolet rays can cause us to get tan. So if you spend a lot of time out in the sun, you might get really tan. And that's because the ultraviolet radiation is causing your skin to change pigmentation a little bit. However, just like we said, be really careful if you go tanning and make sure you wear the right sunscreen. And that's because while ultraviolet rays from the sun can help you get vitamin D and can help you tan, it also can cause skin cancer if you're not protecting against that. Now we get to the electromagnetic wave that perhaps is the one that most people think about first when they think of electromagnetic waves. Those are X-rays. Now, I'm sure many of you have been to an airport. Let's say that you're traveling to an airport and you have with you a suitcase. Let's say that one that looks like this. Well, somebody who's working security at that airport might not know what's inside that suitcase. You could have just simple things like clothes and toiletries, but you could also have some dangerous things in there that aren't allowed on a plane. And so oftentimes when you get to the airport, they will pass your suitcase through an X-ray machine so that somebody can see what's inside. X-rays have really high frequencies, so they can pass through almost anything. And so they'll be able to pass through the outside of your suitcase, even though visible light can't. And that allows the airport to keep planes safe. So one use of X-rays is security at airports, because they can scan the luggage of people who are about to fly on planes. However, X-rays are commonly used in another way. In fact, chances are you've probably had an X-ray taken of your body. And X-rays are used by doctors to see bones and teeth. And this is a valuable thing because it allows your doctor to check if you have a broken bone, or it could potentially allow your dentist to check if you have a chipped tooth or a cavity. Let's take a look at some X-rays now. This in front of me is an X-ray that was taken of a patient at a nearby hospital. If I put it on the screen, we can clearly see that this is an X-ray of a person's chest. We can see the rib cage and their spine, which is very clearly white in the picture. That's because bones, such as the ribs or the spine, absorb X-rays, and so they appear to look white. However, X-rays can pass right through the other parts of our body that aren't bone, and that's why the areas around the bones appear dark. And so using X-rays and the fact that they are absorbed by bones or teeth and appear white, and they pass through other parts of our body and appear dark, is a great way to see if our bones and teeth are intact. So let's take a look at some other ones. Here's an X-ray of somebody's head. Once again, notice the teeth appear white because the teeth are absorbing the X-rays. And the skull also appears white because it's made out of bone, and that also absorbs X-rays. The next picture I'm going to show you is of a broken bone. So if you're a little bit nervous about seeing that, look away for a second. Here's someone who's broken their bone. If you look closely, you can see the fracture right in here. The bone here is a little bit off. And so this doctor would notice that the patient has a broken bone, and they would have used an X-ray to figure that out. Here's an X-ray of a patient's neck. Once again, you can see the spine, and you can also see some of the patient's vertebrae, which are the bones that make up the neck. Here's an X-ray of a patient's hips. You can very clearly see the hip bone in white here, and also the vertebrae from the patient's spine. Now this one is going to be very similar to the last X-ray that I show you in a second. Take a look down here. You can see the joints that lead to the bones of the patient's legs. However, look at the next picture. This is also an X-ray taken of a patient's hip region. However, do you notice here that this leg looks a little bit different from the other? That's because this is a prosthetic that's being used. And notice it absorbs X-rays even better than bone. And that's why the prosthetic appears white and even whiter than the bone on the other side. X-rays can have lots of uses, and since they have really high frequencies, they're great for looking at bones and teeth, because the bones and teeth absorb the X-rays, and other parts of our body allow the X-rays to pass right through. But since X-rays have such high frequencies, they can be dangerous. So don't go for too many X-rays. A couple here and there is okay, but you don't want to expose your body to too many of them unless it's absolutely necessary, because they contain a high frequency and therefore more energy and are potentially more dangerous. Have you ever seen this type of symbol before? Chances are, if you've ever seen this, it's because you saw this symbol as a warning. This symbol means that there is nuclear activity or perhaps radioactive activity nearby. And usually, when there's some kind of nuclear or radioactive activity, that means that we are in the presence of gamma rays. Gamma rays are our final type of electromagnetic wave. They have the highest frequency and the shortest wavelength of all waves on the electromagnetic spectrum. So they would have a really high frequency, but very short wavelength that would look something like this. Because of their high frequency, gamma rays are extremely dangerous to humans. So you might be saying, how are they used? Well, since gamma rays have such a high frequency, they can be used to kill many cells, including cells that are bad. So gamma rays can be used to potentially kill cancer cells, which is a wonderful thing. Some people have been cured of cancer, or at least had their cancer go into remission because of gamma rays. That process of using gamma rays to kill cancer cells is called chemotherapy. And maybe you know someone who's undergone chemotherapy to help treat their cancer. Somebody who undergoes chemotherapy, however, is likely to also lose their hair. Now that's because the gamma rays are killing some of the cancer cells, which is great, but it's also killing some of their hair cells at the same time. However, to get rid of the cancer, most people would take that trade-off in an instant. And so even though they might kill some of their hair cells, they will also be killing the very dangerous cancer cells in their body. Gamma rays can also be used for other reasons. For example, gamma rays can be used to sanitize or to clean places in labs. Now, it's not really safe to use gamma rays to clean things that humans are going to be using. However, if an experiment is done in a lab and that part of the lab needs to be perfectly clean, then sometimes gamma rays will be used to completely sanitize the area because it can kill any kind of bacteria that might also be lurking there. So gamma rays, they kill many things and they can be very dangerous, but they're great if they can kill cancer cells, perhaps in addition to hair cells, but that's okay. And they can also kill bacteria and sanitize certain areas. However, use extreme caution around gamma rays because gamma rays have the highest frequency and therefore the most energy on the electromagnetic spectrum. So I hope you learned something today about the different uses of all the electromagnetic waves. Here are all the waves that we learned about today. We started with radio waves, which I've listed at the bottom because these are the waves with the longest wavelength and the lowest frequency. And we went all the way up, including the section of the electromagnetic spectrum that humans can actually see, until we got to gamma rays, which are the waves that had the highest frequency and therefore the shortest wavelength. Maybe you'll be able to notice some different uses of electromagnetic waves in your everyday life. Thanks for watching.